There we go. Okay. I think we might actually be live again. Sorry about the giant pain in the ass. I'm just terrible at getting this stuff working. But I think we are back up and live.
Yeah.
And hopefully a little bit more real time now. You see yourself like quickly?
Yeah, I'm trying to.
Oh yeah, that's much better. Okay, hopefully this stays steady and we can actually talk to people now. So you were, I think, about to explain some of these different machine learning things, algorithms.
Yeah. So the idea there is that. Okay, so you can see a couple of these. Yeah, we probably should have that in the background somewhere.
I was just gonna run that pip install dot and then move it away. They're going through that setup of getting everything ready for machine learning too.
Can you move that image up on the stream? I guess you can't, huh?
Oh yeah, sure.
Yeah.
Why not?
Yeah.
Just go.
Oh, just drag it up a bit.
Yeah, shrink the browser window a bit.
There we go. Cool. Okay, so yeah, you said that it was using nearest neighbors. So there are a couple of concepts in machine learning. One is supervised learning, and the other one is unsupervised learning. And so many of these are supervised learning, but nearest neighbors is unsupervised learning. Every time you add new data, it just starts making better predictions, and so. What you see here is on the far left, those three sets of data are basically sample data. So you have X, Y coordinates, and then you have red or blue, right? And so for any point on the white space, you can ask what should this white space be, red or blue? And the machine learning model can predict that. So this is like basically making a simple decision on one or the other. Does that make sense?
Yeah.
So for nearest neighbors, every time what it does is if you say I'm going to use a 3 nearest neighbors algorithm, it's just going to say in this case in 2-dimensional space, what are my 3 nearest neighbors using like the traditional distance algorithm. And so just, what do you call it? A squared plus b squared equals c squared type deal.
Okay, so it's like for each pixel here, it's looking at the 3 points nearest to it.
Exactly. And then it's choosing it.
On what those colors are.
Yeah. And so anywhere where it got 1 blue and 2 red, that's where you see the light red area, and that's just because it has lower confidence, right? And then anywhere that it had, 2 blue and 1 red, you can kind of see in many places, except for that 1 red dot, it had like a lower confidence on the blue. And so, so that nearest neighbors column, you can kind of see it's very choppy looking in the decisions it makes versus the others. So then the next one over is like what's called a support vector machine, and it's using lines to delineate the predictions. And then in 3D or 4D or 5D, like it basically will take any hyperdimensional space and then use a hyperdimensional line to draw that line and then make it delineate whether or not to make one prediction or the other. And so the next ones are like radial basis function. That's a support vector machine. It just basically uses kind of circles, if you will, to chart what it thinks is where. Gaussian similar. That's why both of those look really smooth in their predictions. Decision trees are really interesting because it's basically asking, what should it be red or blue, yes or no, given these coordinates. And then a random forest is using many decision trees, and then a neural network is even farther beyond this. It's a computational model of like a human brain, and so that's even more complicated. And I can get into that later if we still have time. And then Ada boosting and naive Bayes and QDA, those are all like ensemble methods that get a bunch of machine learning models together and use them to do predictions. And so you can kind of see the different ways that it would do this. And so for the ball rolling, it's basically saying, given the ball's position and velocity now, how should I modify the paddle? And then it modifies the paddle based on the predictions of whether or not it's going to roll off and if it's going to score it well based on its position and velocity. And so, yeah, so that's kind of like a quick explanation. And so what TensorFlow does is it figures out on its own what the best configuration of these different models are in order to make it so that it can learn the fastest. So, Google released TensorFlow as an open source thing, and that was because they had made some advancements in machine learning that, basically no one else had. And they wanted to make sure that the community began to use more advanced machine learning techniques. And then sklearn is kind of the beginnings of the open source community using these different machine learning models. So yeah, that's the quick intro.
Cool. It's interesting stuff. I've barely looked into this stuff, so it's cool. Like everything you say is pretty damn new to me. Which ones of these are like the most commonly used in a real world situation?
So things like TensorFlow are going to pick these for you, but basically it's going to be different for every single situation. What makes Nearest Neighbors special is it can, theoretically learn as it gets new data, where these other systems not necessarily. So you give it a set of data to learn from, and then it makes new decisions without improving its view of the world over time, where the nearest neighbor algorithm can learn new things and incorporate them in real time, which might be why they used it for training that ball project to show it happening in real time. And so that's the difference between supervised and unsupervised. What you hear a lot about, in the news and stuff is neural networks, and it's the idea of mimicking the neurons in your brain and the synapses firing, the electricity firing between neurons. And so when you give it a piece of data, it basically says, in order to learn this, it's going to create, a theoretical electrical resistance that's represented as a multidimensional array, and that creates a weighting system. And so when your X and Y coordinates are basically electrical impulses given to this little brain, and then it will interpret that based on the weights it developed during a training phase to make it more and more intelligent as you go. And so neural networks are super common these days as a way to learn data, but they're very hard to configure when you're first setting them up.
Oh. Huh. Yeah, I've seen a little bit of just video and documentation about neural nets with the lines of circles.
Yeah.
Yeah.
Yeah, exactly.
Interesting, but yeah, I feel like I need like a real project to work on to really understand it. Like,
yeah.
like
well, so
thing than a goal.
Neural networks are pretty much encapsulated by this library, and TensorFlow hides even more from you. But they show those graphs from what's called TensorBoard, and that actually just draws a diagram out for you to tell you what the machine learning model is doing. Because once you combine two or three of these things together, it's very hard to follow how it's making these decisions, which is why the futurists of the world are so afraid of machine learning taking over the world or something one day. It's because you add more and more of this intelligence into a system, and slowly, people have felt that it gets out of control, which is why Google invented TensorBoard, was to give people more of an idea of what's happening underneath the covers when you tell it to learn something. Yeah, it's pretty interesting stuff.
It definitely seems really interesting. The Pip install is still running, but PyCharm is done.
Okay.
Can open that up and
yeah, so we could do the iris thing if you want. So
yeah,
there's a real simple way of telling Python how to learn how to tell what type of flower, what type of iris flower you're looking at based on the measurements of its petals, essentially, if that makes sense.
Interesting. I think it'll make more sense once I kind of see it in action.
Yeah, I'm looking for a good example of what it's actually doing. Let's see. So that was that other link that I'd sent you. So once we have
right
that,
here, right? The Iris dataset.
yeah. So that the nice thing about sklearn is it has all that junk baked in already. Let's see, PCA, sklearn, load Iris data.
And then yeah, once we get everything installed, we'll jump over to doing some Unity training too, for anybody that's watching and just curious.
Yeah. Where's the Unity?
We're gonna do some Python right now, and then yeah, whenever that's done, I assume probably the next 5 minutes or so. Installer can't take that long.
Hopefully.
Once we're done with some actual learning a little bit of Python training.
You can close that. I think that's just. Oh, actually, never mind. That is a loading bar.
Yeah, it's blocking.
Yeah, so give that a second. But so the data we're looking at, actually, I'll send you one more link. So this is the UCI machine learning database. Learning data sets. Let me see here. This is a little bit easier to look at the Iris data. Whoa. Here, pull up this link while we wait for that.
All right.
Okay, so well, you know, this is the University of California, Irvine. They have like a pretty big machine learning program, and what they've done is they say, you know, they collect a bunch of data that's commonly used in machine learning. And so what you see, that picture there is an iris flower. And there are 3 different types of iris plants. And so if you click on that link that says data folder, it'll actually show you what's going to come back from. So then you can click on iris.data. And so it's basically, it's a comma separated value, set of comma separated values, and it's like different measurements of the stem and the leaves, and then it basically says if it's an iris versicolor, an iris setosa, or an iris virginica, and so then you can take that seemingly arbitrary data and always tell what type of plant it is. And so like that's like the, you know, the hello world of machine learning, if you will.
Oh.
Yeah, and so now you can use those other prediction models to figure out, like, you know, can I predict what type of plant it is based on that?
All right, so we've got PyCharm up and open now, and the data set right there. How do we make it?
Yeah.
You want to take control for a second?
Sure. Yeah. We can. So if it lets me open this folder. Which is not. That's weird.
Is that a folder? No, that's not.
Oh, okay. Are you inside of a project?
Yeah, this is a new project.
So I hit File here, and it clicks on the thing behind it.
Oh, you're actually clicking off. You're not clicking on File. Maybe the mouse is off. So File is right here.
Yeah. I'm just trying to see.
Maybe TeamViewer's a little messed up.
What?
Keyboard shortcut for the clicking.
We just need a new file.
Alright, so file
let's see.
New.
Yeah.
Scratch file.
Sure.
I don't know which one.
Just Python is good. It looks like it was. Here, let me try and move the mouse around. Super weird. Okay, cool.
Oh, you know what? Let me change my resolution here. That might have something to do with it. Plus, it's making part of the screen not show up on the stream. Go down to 1080p real quick. Hopefully, this doesn't break everything again.
Probably a good idea.
Hey, it broke the whole stream again.
Oh, shit.
Did it? Did it go black?
Yeah. It went black.
I just changed configurations. Did it switch back? Alright, we'll be... Oh man, I'm fucking terrible at this.
Might need to do another day.
And it's looking that way. 1 second, let me see.
We lost people pretty quick here.
I bet. Yeah. You're like I'm breaking things left and right. Alright. I just stopped and restarted it. Do we see anything other than my beard? Why is it just my beard? I don't get it. Hold on. I can do this without restarting the stream. Give me 2 seconds again. Team viewer was stealing my mouse. Okay. There we go. We're back. I think. We should be streaming again.
So it's loading something. Oh yeah, here we go.
Okay, cool. Alright. Now we're back at a resolution where things might work better. Okay, go ahead and take control again, Chris.
Did I disappear? Oh, the Skype calls.
Oh, no. My desktop resolution is there. And yes.
Oh, okay, cool.
Your video just stopped sharing.
Oh, awesome.
Did you stop? I don't know if you stopped sharing video and random other stuff is popping up. Okay.
Yeah, Skype like disappeared or something. Okay.
That was weird. Okay,
there we go.
Let's reopen this one. Okay, cool. Now everything is visible. All fixed.
Okay, let's try.
Cool.
Alright. Totally. The mouse cursor is like slightly above mine.
Oh. Hopefully it's a little bit better.
Yeah.
Alright.
Okay. Okay, I think we're good to go. Alright, so quick.
We're gonna make this thing detect flowers magically. Yeah,
so all I'm gonna do right now is show the flowers, and then we can worry about all that other stuff.
Okay.
And we'll just see if you have sklearn. So, thing to know about PyCharm is it does some run configurations. We have to find out where your Python installation is and things like that, but they usually show up here. If you used any of the JetBrains IDEs before, and it's not allowing me to run anything, so that's also awesome. We gotta figure that out. Jeez. Wow, what is happening? All right. File settings. So this will let me pull up the Python interpreter, or project interpreter, right? And then it'll let me say, yeah, use this one, right?
Okay.
So that looks like it's good. Usually it lets me say run it here, but this is just saying run file in console. So let's figure that out real quick. Oh, because it's scratches for console, so let's just make a new project.
Oh, okay.
Well, it says you're in a project, so let's just do this. Oh, that's new scratch file. New.
Maybe it's because you have scratches and console selected.
Yeah, no, it's weird because it just says, okay, here we go. Let's do this. New, there we go. Python file, main. Let's grab this guy, look over here, run this file. Still not showing. Oh, but you do have a run config for Scratch, which is just to run it there, which doesn't make any sense. Wow. They must have changed something. Show in terminal, go to. It doesn't even let you edit run configurations, so we're in some weird state here. And you can't do a new project.
That's weird.
Why would that be?
Yeah, we did a new project to create this. Try closing the project. Can you close the project in here?
Control Shift F10, run configurations. Hey, here we go.
Oh.
That was weird. It's making me do it manually though. It doesn't. It's like it doesn't have any of the stuff enabled. Nope. It created it, but now it's not running it.
Huh.
Shift F10. Yeah, run unnamed is grayed out. I'm gonna try restarting it.
Yeah,
me
go
real
ahead.
quick.
Yeah, I'm
you,
totally lost. So.
Yeah, just go ahead and restart with PyCharm.
Okay, close that out. I wonder how. Still going?
Uninstall protobuf. What? I found an existing installation, uninstalled it, and then installed it again.
Apparently. Alright, we'll relaunch that PyCharm. Put that again for a minute. Hopefully this thing just finishes. Slow. Ah.
Yeah.
Oh, I should probably kill this too. A reason to have that ball running in the background. Things. Okay. And try creating. Oh, it's loading a project.
Yeah, it should be the one that we had. So close that. Really, actually, let's just get rid of this thing, and we'll just do print hello world. Shift
Still can't run anything, right?
Yeah, that's what it's looking like. Looking for any way to do this.
It didn't even do anything?
No, nothing I wanted it to.
Huh.
It's super weird.
It's very strange.
So we restarted it.
Yeah.
You have a project interpreter selected. Can't edit configurations.
You trying to click on file?
No, right.
And make a new one.
It still says new project is still grayed out.
But what if you close project? Now you can just hit create new right there.
Okay, let's try this.
Maybe there was an option there that I blindly missed. I don't know.
New virtual environment, existing interpreter, no interpreter. Weird. Okay. And then untitled. Okay, so we'll just say iris.
I named the last one Iris.
Yeah, I'll just do iris test.
Right.
And we'll see. That's going to shift us to that new environment. We'll see.
Let's see if this works.
See, it's creating a virtual environment here, and yeah, I usually just use a Python environment.
Yeah, I assume you have a
default. Yeah.
See.
So we'll see. Everything's loading. Everything. Why?
Gotta load all the things, dude.
Any questions from the people in the stream while we wait?
Yeah, like, what the hell are you doing?
Yeah.
Python not let you run things.
Oh, why is it taking so long?
Why does it take this long to create a new project? Alright, Chris, Python sucks. Takes too long to create a project. I knew it. I mean, the last time I really dug into Python was literally, I think, in the 90s. Oh, it was probably early 2000s.
Yeah, well, let's see if we can change your mind about it. Let's see if we can change my mind right now. This is rough. Can't even run it. Yeah, same deal. You don't have like a real Python install. You just have the Anaconda Python, huh?
Correct.
Yeah, that's gonna.
That's a problem.
I'm unsure as to why, but yes.
Oh, okay. Well,
it has like
you can either
everything.
install Python or dive into the Unity thing again.
Yeah, okay. We can go back to Unity. I was just hoping that again.
I was just hoping that I could run this. So actually, what we could do is just use this as an editor, and then open in terminal. And then let's see, main.py.
We're using Python for the machine learning stuff. So we're about to start trying to train some machine learning things in Unity, but it still uses TensorFlow and Python to do the actual training. And while everything was installing, just kind of playing with PyCharm. Chris is showing me how it doesn't work.
Yeah.
And, hey, it's just my system configuration's a little bit jacked up for this. So we were just going through this while we were waiting for the installs to all finish. Let's see if you can make it work real quick. But he's gonna do a quick little demo of iris detection, just detecting different types of flowers, showing how it, kind of trying to explain what the machine learning stuff is doing and how it's working, so that it makes a little bit more sense when we're doing it in a game, and I know what it is that's happening and why that stuff's happening. Oh, you have a play button. Oh, you're gonna allow access?
Well, no, with your permission.
Oh, won't let me? Here, let me click it. It moved off the screen. Hold on, don't move the mouse for a second.
Yeah.
Gotta minimize all this stuff to that. Wait, where did it go? Did we select it? Never mind.
There you go.
Maybe we clicked it. It must have got clicked.
All right.
Does it run now?
Hello.
Oh, it said hello. Okay. So Python is now saying hello.
All right, I'm going to just test one more thing real quick. Apply. Okay. Run this thing. Boom. Okay, cool.
Okay, cool.
Yes.
So now we're going to do the iris thing real quick.
All right. Yeah, I can throw that together.
We'll do that, and then we'll dive into a Unity example.
All right. So this thing,
help me understand it more too.
Has the default data, and we're just going to load that data real quick. So this thing is just so the red underlines right now are just saying that we don't have this stuff installed.
You need that
so
import option.
Yeah, so that'll just let us install it real quick. So the bottom right, again, another loading bar.
Okay. How did you do the install there to make it appear?
Alt enter.
You hotkeeyed it. Okay, so you just went over it, Alt Enter, and then was it like the first option? Oh, install package right there.
Yeah, so these are the different package options, and so it's currently should be installing. I can't tell if it's animating. There we go.
It says 2 processes running, yeah.
Yeah, so in there, oh, I did it twice.
Okay.
So once that's done, then we should be able to just say this is the data.
Oh, okay. So is this sklearn like just a set of data?
No, so sklearn has some data in it, like for getting started, but then you can go ahead and print them out basically afterward. And so actually, and you can use it, but it's as if you loaded it from a file in this case. So we'll print out the data, and then we'll just say print done. And Shift F10 to rerun it. So right now, no module named Numpy, so it's I think it's freaking out because we're missing something, another dependency, which we should have.
Well, it's still running.
It's still running something.
Right now, so
yeah.
Maybe it got it.
More time.
Yeah. Then. Oh no.
We'll do this too. Or let's see, import numpy as np, and we know that thing is not there. We'll install numpy, which should give us another thing down here.
Nice. Nice, easy importing.
Yeah, it's basically doing the pip install command that you did earlier.
Oh, okay.
But whenever you import something, it will it'll basically do that.
And Pip is
it'll
kind
do
of like NuGet, right?
Yeah, exactly. And so if you make a requirements.txt inside of the Python project, then it will just basically, you can just list them line by line, and that'll install. That'll be used to. It'll just go to pip and pull all the Python packages dependencies. So Numpy is a little bit special because it uses some like weird stuff, but sklearn should have known to import that stuff. I don't know why it didn't import Numpy. But also to answer that a little bit further, why are we using Python? Basically, there's like two main machine learning languages out there, R and Python as well. So typically, if you're doing machine learning, you might be in F# or some other languages out there, but in like 90% of the cases I've seen, you're either in Python or R, or you're using something like mathlib. All right, so that looks like we should be able to run something now, hopefully. Oh, it still thinks it's gone. Oh, SciPy is missing. Oh, it's crazy. All right. So yeah, I agree with
what does SciPy do?
It's also another package, but it doesn't. We need to tell it to go get it. I think it's got to do with your virtual environment stuff. It's just not picking up all the dependencies we wanted.
Oh.
Yeah, look at Tiago's chat.
Similar problems with the Anaconda install.
Yeah.
So all this stuff is going to be gone with the next project, right? Or does it keep that virtual environment for...
Yeah, you could select that virtual environment again. So the idea would be, is like, if I want to do a machine learning thing, then you might just say, okay, I'm going to go use my machine learning thing and virtual environment, And
so it's
then,
it's a lot like those Anaconda ones.
Yeah. Well, it did. So when I started this project, it created a new Anaconda virtual environment. So if we go to the run configuration here, it was saying this interpreter, so iris test, and those are the only ones that it knows about.
Oh.
For those interpreters there.
So it actually made a new one. Okay, cool.
And we're just waiting for this guy to finish. You want to check?
Slow. Is it just that it's got to just be that their servers are slow? These can't be big files.
Yeah, I think so.
Yeah.
All right. So still installing something, but we can see what it does now. SciPy live version import Numpy version.
Well, I didn't finish the SciPy one.
Yeah, it's still going. It's like partially imported right now. You can kind of see that spares is there.
Might be done.
All right, let's try it one more time.
Gonna generate some skeletons for us.
There we go.
Oh, okay, cool. So this is that iris data you're talking about, right?
Yeah. So this is all of the measurements, right? Comma delimited. They're basically arrays of numbers, right? And then down here is all the target data, which is all of the results. So for the first element in this array, it's going to be the first. It's going to be a setosa, right? And then for the second, for anyone that's number 1 here, whatever index that is, it's going to be a versicolor, and then a virginica for number 2. And then basically all this top data here. So if you shuffled these, you wouldn't know which one's which. So that's kind of the next bit. So let's see. So
Can you scroll back down there one more time?
Yeah, let's up. I think you can actually...
So on those data points represent... each of those represents an index in that array, right? That array above?
No, so this one is index 0 of this array.
Yeah, so it's like the first
equates
one...
to index 0 of that array. Yeah,
and then the next one there is index 1 of that, and it's saying that it's a 0, so it's that first type of iris. And
so you get
about a third of the way through, they become the second type.
It printed out a dictionary, actually. So what this said is, if I do .data here, data.data, that will give you just the input data.
Oh, okay.
And then
The other one were keys.
Target, I think. And so you can kind of see them separately, right? Yeah. So that's the printout of that array. Right. So so what you want to do is you want to learn the data that equates to the targets, and then that'll spit it out. So finally, let's see, sk learn iris. I just lost the page. I'll copy some code over just to make this fast. Okay. So we loaded the iris data set. And then they just assign these to variables. So they like to use X and Y. So X is the inputs, Y's are the outputs. And so it's like kind of like taken as an algebraic thing. And what they're doing here is this is a slicer. And the slicer in Python allows you to cut up arrays in whatever way you want. So if I print this, you'll kind of see the sliced data. Iris is not defined. Oh, sorry. Data is iris in this case.
Data.
Oh, actually, whoops.
You doubled it.
There you go. So it only took the 2 columns.
Okay, this is first
out
two
of
columns.
The 4. Yeah. So that's what the slicer did there.
And what's the reason for doing that?
Basically, so in machine learning, the presence of data can be just as damaging as the absence. So what can happen is you could have outliers or useless data, and so and it can actually make, by removing some data, it can actually make your predictions better. And so one thing that you might do. Actually, let's just extract this as a variable and call this iris, and that way we can deal with it that way. And then, actually, here we go. Data, I'll just say iris.data, iris.target is the X and the Y. And so we want to learn it with something, right? And so actually, let's just do a sklearn svc. So remember that support vector machine that we saw in those other examples?
Kind of. You want to pull that picture back up?
Yeah, so...
There should be a Chrome tab up here with it.
I don't know if...
It's the... I tend to have way too many tabs open.
Here, we'll just go back over here.
There it is.
This thing. So this guy... Basically, so support vector machine. So we're just going to draw some lines through it. So it's going to be, this will actually give you a really crappy prediction, right? But we'll just use it for an example. Okay. And so let's see. I want to get the SVC. So the SVC stands for support vector classifier. And so then we have the classifier there, and I'm cutting up different examples. Okay. And so what's cool about this is that, so the classifier is a new SVC, that's an initializer, right? It creates the object. And then what it'll let you do is, the fit is the learning, basically, right? So this is learn the data, right? And then we basically then say, we're going to predict some data. So if I gave it a new plant, for example, then it will tell us what plant it thinks it is based on that. And so that print will now say, oh, it thought it was a Virginica based on those measurements I gave it.
It learned it with the fit and then predict returned back the
value,
which is 0, 1, or 2, because those are the ones that we've trained in there.
Yeah, and so if you gave it all of the data again, ideally it should have learned everything, right? But it won't be a great prediction because we used a vector machine by drawing those lines through. And so what it'll do is it'll give us an array of what its predictions were. So you can kind of see it predicted actually all of these correctly.
Oh, okay.
But because remember it was like 0, 1, or 2, so all these 2s were wrong. Yeah. And then it started predicting the 2s and had some 1s in there. So it was actually, because we drew a line through this data, it only learned,
you know, one or the other. And so that's what we're doing here. And so TensorFlow is just a really advanced version of this. It's much better than that. And so you can actually use the nearest neighbors algorithm to do the same thing in that sense. So yeah, I don't know. So that's like a really simple, you know, version.
But it's more of a sample of it partially failing.
Yeah. So like if anybody's trying to like predict, you know, horse races or other things, like you might put in like the horse's like age and muscle capacity and all this other stuff, and you might be able to predict the winner for a horse race, you know, stuff like that. So machine learning is being used in all kinds of sports and all kinds of other things, gambling and all this stuff now.
Yeah, I think it'd be interesting to play with it just in that sense, without losing any money. But yeah. It'd be cool to like just kind of figure out if you can. I assume somebody's doing it, predicting.
Well, yeah. So the stock market crash in the 80s was all basically machine learning models were all doing the majority of the trading. And what happened was the crash was caused by some outliers in the data, and then all of the models started selling the stocks all at once. And so, you know, it basically allowing the computer to learn and automate and predict what it should do based on the other actions. All the machines compounded on each other, and they sold off everything, basically making everything crash.
And that was in the 80s?
Yeah. So today it's controlled even more directly. But yeah, there's definitely some crazy history there.
That's nuts. Yeah, I got a friend who was doing some stock trading stuff, and it was all automated. Like everything he was doing for a company, like doing the stuff that interacts directly with the systems.
Yep.
Sounded crazy, but
so this is the very basic way that you get started doing that stuff.
Yeah.
It was the AI uprising, exactly.
Cool.
So yeah, we can go back to Unity now.
Yeah, we can try training the balls again. See if we can get that working again. So the pip install dot is done, and if we go back over here, take a quick look at where were we? We were not on. Were we on this one? Yeah, training the environment. No. All right, like I said, way too many tabs open.
Yeah, way too many steps also.
Yes. I don't even remember which one it was. Oh, I think it was this link. Because this is the one that builds the executables and then shows us the stuff working. Okay. Where was that? Now you get to see how I bounce around web pages. It's terrible.
Yeah. Search for the pip install dot.
Yeah. It was definitely not this page. Okay. Oh, actually.
Same deal.
I think it might have been a link off of this one. Where did I lose it? How did I lose the set of instructions I was following? All right.
Maybe in here somewhere. Try the first two tabs on that one.
This one or this one?
I think it was that last one. Yeah, there we go. Maybe. There
yeah, right here. Okay. GPU training. Okay, GPU is not required. Okay, this was... Oh, that was the setup. Okay. And this should already all be done, I think. Yeah, I think I ran through all this before. I think we should be good. Okay, so then if we go to the console, I should be able to run these two and not have an error. And if that happens, then I think we're good to do the actual training.
Sounds good. Yeah, you're not in the Python. Type in Python 3. Python? There you go.
Then import tensor as TF. All right, come on, work. Okay, that worked. And then this is where I had problems last time. Not last time, but in January. Okay, no errors.
Sweet.
Good.
Import is not recognized as an internal command. Oh wait,
that was before.
Yeah. No, you're good. You're good.
All right, cool.
All right.
So that is good, and then I think we just go on to the basic training again, if I remember right. So then we open the command terminal, browse to that learn folder. Here, let's just
Oh, I think now you can just set the model to do external, or maybe not. I think now it's the other tutorial. Because we just want to watch it learn, right? That was the...
Yeah. Is it in this one or the other one? This guy show you how to use pre-trained and show you how to train the model yourself.
Yeah.
Setting it up. We've done that. Running the pre-trained. We already did that. That's what's running back here, by the way. If anybody didn't see it, it's just this. So when you run it pre-trained, you got to switch the brain to we just switch it to internal, and then the ball model. It's a file in there, but it was already pre-assigned in the demo. So there it is, running already trained. And then if we go back over here, we want to get to the part where we're going through Jupyter and training crap. Okay,
so set it to external on the ball 3D brain.
Okay. That is the next step. Go to external. Okay, and then what do we do? Really should close some tabs. One of these days. That's not the right tab. That's why. This one right here. Okay, so we set it to external, and then open a command prompt.
Try hitting run with it on external.
I think we're supposed to do a build, too. Okay, let's do that. I'm just gonna move that tab around. Okay, so hit play with it set as external. And not much happens because I think it's because it's not running. I think I need to run the training.
Oh, from the command. Yeah,
so
that makes sense.
Need to run learn by with the identifier and train it folder. Okay, and then when it says to start training, then we hit it. So let's do that. Run
identifier is a string used to separate the results for different training runs. So it's whatever you want, probably.
Yeah. So you learn.py run -id first run.
You need an equal sign in there.
Oh, thank you. I would have missed that and spent the next 10 minutes trying to figure it out. Can't assign to operator. What?
Sweet.
What does that mean?
Syntax error. Can't assign to operator. Oh, try getting do an exit.
And then do Python with it?
With parens. Exit with parens. Yeah, that works.
So should I do like Python, learn py?
Yeah. Because you're giving it command line arguments here instead of writing Python code.
That makes sense. Okay, so this should kick off and then tell us to start the hello Joe. Oh, my son typing in chat. So this should let us start running it in Unity once it's ready, right?
Yeah, I think it's running now. I think if you
Okay. Allow access.
I guess it's just Google wanting to spy on you.
Yeah. Okay, and then now it says to go into the editor. This is definitely better than the last time I did this. Couldn't have
sweet, because I thought things were getting a little drawn out.
Okay, so there we go. Now we can see it actually doing some training. And then I wonder, does the
drop?
Does it show info here? It doesn't. It's kind of like the info about what our settings were.
Curiosity. Oh yeah, it's starting to balance a little bit, maybe.
Interesting. Oh, okay. So we are getting some info back in here. Gonna explain what the hell that means. They got step 1000, mean reward, standard reward.
Yeah, so 2,000 runs so far.
Yeah,
So
go ahead.
yeah, so rewards typically will either be like the highest number or the lowest number. Um, it could be that that's the number of seconds it stayed on the paddle with the way it was trained. Um, and so each time it gives you one of those, it's learned a little bit, and it's going to try and use that information to get a little bit better the next time. So each time it runs, it will attempt to do it.
It's just trying to get that reward higher and higher.
Yeah, I think so.
Is it just going through those different machine learning algorithms that we were looking at earlier and trying them out to see what it does, or?
Yeah, I think so. TensorFlow, what it does is it dynamically creates a model as it's learning, from what I can tell, and so, or from what I've read. So basically, if you do a tensor board, it will give you like the resulting decision-making process it goes through to do anything. So yeah, it may use nearest neighbors and then a neural network connected to nearest neighbors, or it could just use a neural network or whatever based on the different tries that it does.
Oh, okay. And since it's doing a bunch of tries, is it just trying like a bunch of different combinations of stuff to see what works best?
Yeah. And so when it stays on longer, so now you can kind of see it tipping up whenever the ball's about to roll off and stuff. Like it's getting a lot better than it was, right?
Oh yeah, it's dramatically better. Yeah, and we're like a minute and a half into training. Like,
yeah,
thing's barely been trained and it's already significantly better. It's almost keeping the ball steady.
Yeah, that one in the middle there is doing pretty good.
Oh yeah, that is staying nice and steady. Oh, it fell off times.
Yeah. So anyway, it's that'll get better and better as you go, and then that you could theoretically reuse that trained model. So I'm interested in whether or not you could just deploy that to mobile at that point or something. But
I'm almost positive you can. In fact, I think I did that already. I think I did it on my Note 4 and deployed this balls. I remember doing it now. It's been a long time, but I did the balls demo onto it, and it went fine with the pre-trained file.
Yeah. So yeah.
So it's getting pretty good. So do you think we could do like a simple training to get a thing to move to a place or something?
Yeah, I mean, so I have no idea what is happening in those files inside Unity. Like, we got to go look at those files and figure out what's going on. But they have the ball agent, the ball decision, and the hard agent CS files.
This looks pretty good. I'm just gonna stop training it so that we don't spend forever training. But
yeah,
I think it's getting good enough. It's not at the point where that final one where it's holding them perfect, but stop playing and see what happens and start looking at the code, I guess.
Yeah.
Okay, so then this gave us a file, right? So this saved off the model file. Yeah.
Yeah, based on that number that the first run / model.
So here, let's just show. So if I switch to internal and hit play, right now it's on the pre-trained one. It should be like that perfect balance, and then we should be able to switch over to our just trained model. Like, this is the one where it's like super even, and then we should be able to switch to that other model. I just need to find that file. So it went into here /model /first run. Just open that up and grab the files out. Models, first run, and it's the bytes file. Here we go. Just take that, and I'm just gonna drop it into the root of our project or something. Yeah, let's just drop it straight in there. We'll hook it up and make sure that it works too. But it should semi-balance them based on that level of training that we did. Alright. Drop that sucker in there. Graph model, hit play.
Oh, weird. Okay.
And Yep, there we go. Now it's running at about the level that we had just trained it at. It keeps them on, but sometimes drops them, and they kind of wobble around a bit. Perfect.
Nice.
Hey, how's it going in Egypt? Saw a chat message. Nice, early in the morning, right? Okay, cool. So should we look at you want to go through some docs first, or do you want to look at
Yeah, I mean, so they had a tutorial there on making your first model, right?
Oh yeah, yeah. Why don't we do that real quick?
Sure.
Where was that one?
But yeah, I think there was a pretty good demo that I saw that was just, you know, a square gets dropped onto a field and has a color set on its mesh, and that color is supposed to be what, you know, the item it walks towards, and you basically tell it to go to one or the other, and it randomly respawns whenever it makes it to its goal.
Huh. And was it this one?
I don't know. Yeah, I think train versus heuristic training. Okay. Yeah, there's that using machine learning in a real game beginner's guide. The second one down.
Was that the one that had the
No, I don't. There's like a demo of it. I think that was like a simpler.
I wonder if it's just in the project. Let's take.
It might already be there. Yeah.
Examples. So we got 3D ball, maybe basic. This looks like. Save. Just a cube. Got a large goal and a small goal.
I think that's right. Oh, maybe not.
Okay. Oh, it's probably set to player. So by default, when you select these brains, at least in the examples that I've seen, they're on player mode, which just lets you move them with the keyboard. But let's set it to internal, and it's already got a graph model there. Play and see if this is doing what you're saying, and then okay, so it's moving to green, moving to green. It's always moving to the big one.
Yeah, so maybe move it around. What the heck?
I don't know. There's a goal, and then what is this one? This is a.
Did you set it to internal or external?
I set it to internal, so it should be using the previously trained data. Okay.
Yeah, that did not do anything I expected it to.
No. Here. Set it to external and have it train.
Sure, why
Let's
not?
do. Oh, whoops! I used the same name. Whatever. We'll overwrite that file. Alright. Start training. Press play. One other thing I noticed, by the way, when I was going through, there are a lot of settings in TensorFlow. Like I was using Jupyter last time and going through all the settings, and it was confusing as hell trying to figure out like
oh yeah,
what it's supposed to do. So it is like the video that you're seeing of it chopping around, like that's how it's running on my system too. It's not it's not a video delay. It's literally like going at less than a frame a second. Yeah. Or yeah, it says 1.8. It's a lie. Okay, so I think it's trying to train now. Should we just take a look and see how it's trying to train?
Sure. Yeah.
Just open up the basic brain, I guess. No? How do we do this? How is it set up in here? Stop. Responsive. Okay.
So
So there's an agent.
oh, they have a class called Decision.
Oh, where's that?
Okay, so open up the code to the project and just go into the basic folder under scripts. Basic Academy.
Is it in Basic Academy?
Yeah.
Okay.
Oh no.
It's Basic Decision. Okay, what?
Yeah.
What uses Basic Decision? Basic Academy. Is it basic agent?
Well, so basic agent, I think, takes decisions or makes decisions, I think, and then the decisions get executed. Vector orbs, visual orbs, reward, done, memory. Make memory.
Alright, it's opening up now. So make memory is just returning back a new list of floats because it doesn't have any memory, right?
Got it.
And then whenever Unity finishes opening, oh, look, fixing some fizzle code recently.
What I mean, so something.
Your head over your head. There we go.
Get it off.
All right. Yeah, we'll have to look at that, Paul. I'm not sure. He's saying that he thinks maybe it was the goals have a cost and there's a movement cost, or the goals have a point value. There's a movement cost. Okay, so decision is not very bright. It seems like it just returns 1.
So movement, vector action, get vector action, agent action.
Some of this stuff.
I mean, okay, so basic agent has all the guts of what's going on here.
Okay, yeah, let's take a look at that.
Get is inference, request a decision. So it runs something called request decision, which I bet is part of the agent subclass or base class. Like if you go look at the inheritance at the top, you'll see that's pulling from agent.
Yeah, let's check that out. Oh, we actually have the code for agent too. And then you said it was using which method in here?
Request decision. Yeah, right there, up there.
Okay. And request action, which just sets request action to true.
Sweet.
And then, well, here, I guess let's just do a shift F12 on that. So on reset and send info. So in send info, if request decision is made, it sends info to the brain. Okay. And what does that do? It's just, I think it's sending in that those vectors.
Yeah.
Not sure how that works or what the hell that does, but that's what it's doing at least. Alright, so the basic agent also has a bunch of public fields that are probably set. Take a real quick look at those in here. Go to the agent. You can see that the large goal is defined right there. Okay. Oh, and the positions right here are defined. So that's why when I was moving it around, it wasn't doing anything. Because it was resetting them every time when it was doing the learning here.
Yeah.
Okay.
So movement gets set. I just don't understand ultimately what's moving. So the agent reset just puts everything back, right? Small goal, large goal, positions get set.
Yes. So position. Here's where it's actually moving, and it looks like this is just going like a positive to negative on there. Like if you look at it, it's just moving along that x-axis, and it's got like the positions are just integers. It's not vectors, so it's a large position of an x value and a y value to try to get to those goals. And I assume it's just gonna. I don't know. Let's see. So
yeah, my question is, what is it doing with it?
So I vaguely remember what the way this works, and I think when it's doing the training, it's passing in a random vector or whatever it wants to test, and then it's going to decide true or false whether it should move negative or positive, go left or right, I guess. Yeah. And then adjust the current position. It's funny. This is kind of similar to the first one that I tried code myself, and then it. Oh, this is just clamping. So the position can't go past the min and max. Moving the object, and then adding a... Oh, that's right. So, I don't know if you can explain this a little bit, but I saw in the... in some of the examples they're talking about just subtracting a little bit of score every time it takes an action so that it finds the most optimal way to get there.
Yeah.
So that like every step that it takes reduces the score by a little bit. I think that's what it's doing here. And then it checks to see, I guess, if it reached the actual position, it adds a reward of 0.1 for small goal and 1 for large goal.
Yeah.
Okay, so when it's fully trained, it should be really, really
always going for the 1. Yeah.
Unless it gets to the point where it needs to move 99 times to get to it, right?
Yeah.
Because then the reward would be, or I guess 91 times.
Oh yeah, okay. Game object transform position. So line 50, right, is the...
Yeah, this is where it's actually
the movement.
The thing left and right. It's just moving that X value. So yeah, I think, yeah. So if I'm right, then if I switch this brain over to internal, the previously trained one, the one that always goes for the big cube when they're close. This.
You need it.
Right, or it always goes for the big circle. But if I move the
agent reset puts the position back every time.
Yeah, so I was thinking if I move the large goal like 90 away, it should still go for the large goal. Oh, and then this would be like a 100. Stop and try it again. So I think if I set this to like 90 and 100, it's still gonna go for the large goal. But then if I crank it up just a little bit more, it should start going for the small one. Let's see. It didn't even work. Is it hard-coded?
It's hard-coded under agent reset.
Oh. That's what you were just telling me. And I was
not
paying enough attention. Okay. So large goal position. So let's go to like a flat 90. Just to... There we go. So try this. It should. I think it's still gonna go. Am I wrong that it'll still go for the big one?
It depends. Well, it subtracts it. It depends on if that's on delta time or not.
It's not. It's per frame because it's moving by 1 unit per update. Okay, so it's still going for the big one. Oh, but then it's
No, it still thinks it's going to that one spot. It's just going back and forth right now.
Why is it trying to go to that one spot? Is it not very smart?
Maybe...
Is the brain only trained to go to that hard-coded position?
I think so. I think it is.
So if we wanted to train this to go to any position...
Because it only moves on a line.
Yeah.
So, yeah. I mean, there's a lot of work there. I think there's probably a different example we would need for that.
Well, I mean, if we wanted to make it move just further out on a line, for instance, like as a...
Oh, yeah. So for that, I think you need to retrain it.
So what if we wanted to make it be smart enough to go to any point on the line? Could we have it pick a new position every time it resets?
Yeah.
Like a random position for the thing?
I think so.
Okay.
But it would need to be able to take that information and so that's the thing, is that memory isn't being used, right? So my guess is that deciding and making a memory have some part to play in that. But since it doesn't have a memory, it only knows what to do in one scenario. Wait for time, inference, request decision, else if time since decision was time between decision and inference, decision, request decision. So calls request decision over and over again.
So I'm gonna try it like that. I don't know if this makes any sense, but just picking a random value. Oh, get rid of that. Picking a random value and having it train against that real quick.
Yeah.
See what that does. Just, I don't know. I think I'll learn a tiny little bit from it.
Yeah, no, it sounds good.
So pick the brain, switch it back to external, and then when this prompt pops up and says we're ready, then I can hit play and it should start training. So I set it to pick a random spot between 10 and 30 for the large one.
You might want to give it a new name. You're still on the first run.
Oh, for the file, yeah.
Yeah, I don't know. I mean, you could just wait and see what
It's just
happens.
overriding that file. I was copying it out of the folder though. Okay, so now it's training. Oh, but you know what? This is gonna train like super slow, isn't it?
Mm-hmm.
You know, and that's because we're wait. How does it say step 2000? Does that mean what is? That mean it tested 2,000 times? Because it didn't seem like it did.
Yeah, 4,000 now. Maybe it's going so fast that
Just not able to keep up on the rendering side.
yeah.
So my mean reward went down. Is that a bad thing or expected?
Possibly. I think so.
And then it went back up. But I mean, I am picking random positions for every training.
So Paul says basic brain is likely overfitted due to lack of goal position variation during the training, and yes, I believe he's right.
Okay.
But
theoretically, this should be.
Yeah, the reward number should be growing, but there's no memory, and I think that's the problem. Like, I think there's a problem right now. I mean, it might get. Let's see if it's moving randomly. It needs to know what to do in the case that the position is different each time. So I think gradually over time you might get something out of it.
Oh, okay. And here we're only training one at a time, where the other thing we were doing like 12 or 16 or something like that.
12 of them, yeah. So yeah, look at that. The reward's kind of slowly going up on average.
Oh.
Yeah, 2.2, highest value now.
So which number matters more, the mean or the standard?
I think just the reward. Mean reward of the reward, yeah. So now, I mean, we're not. Yeah, so if you save that off, oh, it just went down again.
What's that?
It just went down again. It might be the random numbers selected fit what it's trained for more, but I'd expect it to go up again the next round. Could be rough.
Is it still running? What's going
Yeah,
on?
I don't know. It feels like it's dead.
Well, I think Unity feels very locked up.
Memory leak, maybe?
Don't know. Nothing's anywhere near what Chrome's at, so yeah, Unity's time.
Yeah, Chrome's the one dying.
Hitting enter in the prompt fixed it.
Weird.
I think I had clicked and dragged. It broke stuff. Okay, so here, I'll stop training. I'll try to stop training. Hold the button down. Try Control P. Been using that a lot lately, by the way. Just hitting Control P tends to work when clicking doesn't. Not working right now.
Okay.
Not
It's
helping
dead
at all. What is it? Control Q. There we go. I think I just needed to kill it in here. Okay, cool. So that saved it, but I don't think that model is very well trained, right? So what should we look at next? What do we want to do?
So this position variable. So anyway, in the code, I'm just looking at the code still.
Okay.
This in the basic agent for that. So line 25, there's the collect observations, and it just says add vector orbs.
Well,
Which
vector OBS.
OBS, sorry, not orbs.
Objects? Obs?
Yeah, obs.
Oh, observations.
Observations.
It's an observation. Okay, add vector observations.
So then under the decision, right? So if you go to basic decision, it takes in the vector OBS, right?
Yes.
And it's like a list of them.
Oh, okay.
And so
And
and it also has visual, which is really interesting too. I'm like wondering if you can just send it pictures of what
you
the
can send it
camera
the
sees.
screen. I
Yeah.
remember you could send it like the output on the screen.
Wow, that's crazy.
You have it try to evaluate based on whatever the player's seeing. Or
So
some other map, I guess, too. You could always mix that up and show it something else.
So here's the thing: is that the agent base class on basic agent has this function on it called add reward, right? And then also on the basic decision, it also has this reward and then memory. And so I think what's happening is, well, I don't know.
Should we look at an example that's using make memory where it's?
Yeah, I think so.
So let's see. There's like the ball decision one. That returns an empty list.
Make memory that returns an empty list. But what's interesting here is that decide actually has something in it.
Oh, on the ball?
Yeah.
Oh, yeah.
Brain parameters vector action type equals continuous act. So state 5 is the velocity of the ball in the x orientation. We use this number to control the platform's z-axis rotation speed so that the platform is tilted in the x orientation correspondingly. Vector 5 times rotation speed. State 7 is the velocity of the ball in the z orientation. Act.toArray. Return act.toArray.
Oh, it's just a list.
Yeah. But so it's a list of floats. So it's just saying, set my rotations, right? And then what does it do with that? So the agent action takes a vector action and a text action, which is super weird. Oh, collect observations. So the Z, the X, the position minus, or the direction, and the velocity. So if you go over to line 17 on the ball agent,
collect observations, okay. That adds a vector one for the rotation, the Z rotation of, this is the paddle, right?
Yeah, maybe.
I'm pretty sure it is, because it's got a reference to a ball.
Okay, yeah, it must be the paddle.
Just double
we
check.
gotta open the scene,
Easy
right?
enough to open it and make sure. So we open up 3D ball.
Platform agent.
Save, and then 3D ball agent is on the platform.
Reset on done, on demand decisions, decision frequency 5. Oh, so you can set the decision frequency, whatever that is.
Huh.
It's interesting. Vector action space type, continuous, again, rotation.
So
it's rotating.
In the agent action, I think, I could be wrong, but it looks like this first part is just attempting to, is it trying to counteract? Oh, okay, no, it's if it's within an acceptable range, then it'll act. If it goes too far, it stops. Is that what happens? It's checking to see if it's greater than negative 0.25, unless, so yeah, it's, why does it do that though? What does it do if it's not, if it's like out of range, if it's rotated too much? Just not.
No, so you know how the paddles don't flip around? They don't flip over. They only wobble.
Yeah.
That's causing the wobbling. It's just saying don't let the paddle rotate too far.
Right, but how does it rotate away if oh, it's looking at action Z. Got it. Never mind. I see.
Yeah.
It's saying it's basically clamping that rotation so they can't flip all the way over and just go crazy.
Yeah.
That makes sense. Which is also to keep it at that realistic, like it's a paddle.
Yeah.
Okay. And then oh, it checks to see if it's fallen too far.
Yeah,
And
the Y
if it has,
position.
it sets the reward to -1 and calls done. What does done do? Does that mean like, oh,
That's part of the agent.
it just means it's time to try the next training, right?
You know,
Overrides current step reward. The agent updates episode reward accordingly.
yeah, it's telling. I think it's saying get the last learning and move on to a new. Like it's actually a base class, agent base class thing.
Oh. Huh.
So yeah, these are all like magic functions on the base class.
Yeah. Okay, so if it falls off, it sets the reward to -1. Like, sets it to done. And otherwise, it adds a reward of 0.1 for staying on for that decision time, right?
Yeah.
Or for that action. So it didn't fall off yet.
So decide returns arrays. And vector action might be the decision, because 0 and 1 is the action Z and action X, right? So I think that's what's going on. Is decision says I'm going to take my observations and multiply it by my rotation speed and then pass it back, and then agent then takes those observations and translates them to a clamped action Z, action X, which then allows it to rotate. Whatever that step might be on the rotation.
Which one are you looking at?
So I'm bouncing back and forth between agent action on the ball agent and then decision on the ball decision.
Yeah, because we pass in action Z, which is that vector action 0, and then action X. Yeah, so it's getting them. I think you're totally right. It's getting them from the vector observations that are passed in, which are the velocity of the ball in X and Z. How do those get passed in? Velocity of the ball.
I think that what that is the collect observations. So I think the loop is, it says the agent base class.
It's right here.
Yeah, exactly.
It passes in that velocity, which is a vector 3, and then it's just using that as X. Okay, so vector observations must just add all of the vectors to the float, or to that float array.
Did it say?
That makes sense, because this is 0, 1, 2, 3, 4, 5, 6, 7.
Yeah.
This is a vector 3, so it's
and it's 5 and 7 that it's using.
5 and 7, so that would be the X and the Z value of the velocity of the ball. Okay.
So you override collect observation. Yeah. You do collect observations, then it uses that to pass in decide, and then decide comes back and says, this is my new action based on the decisions.
Oh.
And then it loops over that over and over again. But I don't understand how the action gets changed each time based on the reward. I guess the decision is still something feels magic-y. Reward, because you get reward back, and it doesn't feel like it's using the reward to make a decision. Oh, rotation speed changes, maybe? No. It just says rotation speed is 2, so it's just saying take the value of the velocity of the ball in the x orientation and multiply it by 2. Doesn't make any sense. Like, what is the agent changing for us?
it does that.
Yeah.
Does that. How is it? Class. Yeah, I don't know. Where does the action come from? Current agent action. Message being sent from brain. So this is totally confusing.
Yeah. It just feels like it shouldn't be. So if it just takes the observation, multiplies it by 2, and then adds it to the action array, and comes back to the agent and uses those values and doesn't modify them, and then it just sets the reward afterward, like where is the improvement in its behavior coming from?
Could it be right in here?
The core brain heuristic.
Where it's calling decision.decide from here. I wonder if it's passing in different stuff.
Yeah. I mean, it must be modifying the values somewhere.
Yes, and that's because it's adding to stacked vector observation and reset and send info to brain. I have no idea.
State 5 is the velocity of the ball and the x orientation. We use the number to control the platform's z-axis rotation speed so that the platform is tilted in the x orientation correspondingly. What is this hard agent? It looks like the same thing. Oh, it's learning less, it looks like. Or something. It's collecting less observations. Oh.
Okay, so this is in player mode. Look, I can play it and control them. See the hard academy. So if we switch it over to internal, I assume it's just going to keep it up there the whole time.
Hard mode.
It does.
Did they slow it down? No, the rotation speed's the same.
Definitely not as good at it.
I wonder why. Because the only thing that I see that's really different is the collect observations does less.
Oh, what is it doing?
It's not incorporating the velocity. It doesn't know the velocity of the ball.
Oh, okay. So it only has the position?
Yeah. It has the... But even then, how would it make the decisions based on the data that it doesn't have?
Better question. How does it know what decision to use?
Yeah, well...
Decision 3D. It is not referenced here. Oh, it's a mono behavior. It must be, it's got to be assigned in here, right? On the...
Can you look at the brain parameters? You go back to the...
Yeah, where was that? Right here?
There. Oh yeah, simulation space type
right here.
continuous.
Decision. That's where it's assigned.
Weird.
On the brain. Interesting. So it's not passing in 7 and 8?
Yeah, no, it's not. Well, it's not passing in 5 and 7.
Or 5 and 7. So is it just doing this instead? The space type?
Well, no, but that was why I was asking you to look at the vector action space type, because I think it was set to continuous. Like, I thought, it seems to me like it should be throwing an exception.
It's set to continuous, yeah. I don't know. yeah, that's a little confusing. Action descriptions. Oh, wait. Oh, the observations are set to continuous. Base size of... I don't know what this means. Huh.
So
Interesting.
Paul says to look at the reward to see if it's used anywhere.
Good idea.
Let's see. So set reward, float reward, cumulative reward. So cumulative reward is the thing that is.
Well, there's reward and cumulative reward because it's also setting this dot reward.
Oh yeah, you're right.
But it has a get cumulative reward.
Shh.
This is a unit test. What else is referencing cumulative reward? Absolutely nothing.
It's probably just using the get reward, to be honest. Nothing uses get reward.
Oh, really?
Yeah.
Nothing.
Right,
References
just
that.
find
Does anything
all.
reference reward? Info.reward. Send info to brain. That's the only place it seems to actually be used. And the brain takes in that reward and whether or not it's done, and does some magic inside when you send the state to the brain. Huh. Don't know.
Brain parameters. Okay, so here's my theory. The vector observations are being collected periodically, but they're not, they're just random values at first. But how would it know what length to make that array? Okay, so here's the thing. Can you print out the length of the vector orbs in the decision?
Yeah, on the that's
just the array.
Basic decision. No, it's in
observations. Ball
decision. Yeah, it's just not open. Okay, so just want the length of that.
Yeah.
Just trying to figure out why that is.
Like, so my theory is that that's just like 1,000 long or something stupid, and it's just giving you random values at first, and then as it learns it gives you set values. But if it's 8 every time, like, that would be really weird.
Oh, let's see. Decision is not called, apparently, when it's actually already
should it have been a mono behavior print or no?
Huh? No,
You used a debug log.
Yeah, debug log will show up right now.
Oh, okay. It does. Okay.
But I don't think it's being called. But I think if we switch to external and go into training mode, it might get called.
Still, it's so weird. That might make sense though.
Okay, now if we train, get a nice spam of log entries. Did I just forget to save and I don't know what the fuck I'm doing?
No.
Built.
Call print.
Oops. And we'll attach. Oh, what? That seemed true. Build errors. Okay, that's probably the issue. What the hell is wrong? Okay. Oh, it's not. I'm just not going to be able to attach. Visual Studio doesn't know what the fuck TensorFlow is. All right, let's try this. Oops. Oh, it wasn't up and running it. Gotta restart that training thing. And then reconnect it once it comes up.
Nothing.
It's never called. I wonder. I'd go into the other one and see if it's the other 3D ball sample real quick. The non-hard.
Yeah, because
uses it. Oh, hold on 1 second. Dying
Sure.
headphones. All right. Okay, let's see. Are we getting logs? Console. No. Yeah, I don't know.
Well, right now is the thing running again because it doesn't look like it's. What was the fourth option for player internal and external? There was one more.
Heuristic.
Okay, try heuristic.
Okay.
There it
Get
is.
it with that. And if I switch over to external, now that the training is there, do we see anything here?
Okay, so the brain makes its own decisions based on the reward, but the heuristic makes the decisions for you.
Oh, okay.
So if you set heuristic mode, that's how a decision gets called. So I bet you if you go to the hard example and set to heuristic mode, it'll crash.
Because it's going to not have enough data. Okay.
Yeah.
Or, yeah, we'll get an index out of range exception. Oh, no. No, it's just 25.
the hell?
The size of the array is 25 instead of 8.
That is not useful.
No, but yeah, so the decision stuff's only called when we're on heuristic brain type, huh?
Yeah.
I wonder what that's for. Is that just for making
That-
your own brain?
Yeah.
That does?
Exactly.
Okay.
So
You tell. So I bet you if the player one is probably
just Unity controls.
Yeah.
Um,
And just passing in the values to those actions.
okay, so we shouldn't have been looking at decision at all this whole time.
Right.
It was just misleading.
Is it distraction?
Yeah. So collect observation and agent action is the virtuous loop, basically. So that it will give it a score based on the actions it completed, and then it will attempt to do something new. And it just does that over and over again.
Okay. So if we were back in like our basic agent.
Okay, I have the analogy for you. So in the iris data set, when we were talking about detecting flowers, the collect observations is going to be those the petal length and the stem length, and then the agent action is like the resulting thing it does based on that, right? And so you just tell it what to do with that action. So the learning is collect observations, and then the prediction of what to do or the doing is the agent action inside the ball 3D agent, if you look at that.
Oh, okay. So this is doing the thing.
Yeah.
And then here we also set the reward so that
After the fact.
the brain will try to figure out. Okay.
Yeah, so you have to gradually subtract its reward until to show that it's not doing well, and then it will just attempt to randomly, and then that reset basically creates one new row of data each time. And then you have to go through thousands of iterations to figure out what to do.
Oh, okay. And when we do the 1,000 actions or whatever, where was that? In here where it was saying, what did it say? Stupid text on there, like the steps. So is each step like an agent action then? Or
Yeah, I believe so. Every time you call done is one step.
Oh, okay. So whenever we reach an endpoint, or yeah, I guess that's it. On this one, we only ever call done when we reach an endpoint. Either the small goal or the large goal.
Yeah. So it was like 12, 12 of those maybe per second, I guess, or less. 12 every half second when they fell off, right?
Yeah. Okay, so if we trained this with the default, it's going to take a little while to train, right?
What do you mean? Oh.
Like, if I just used these default values and went through and actually did the training even on that basic model.
Oh yeah, so basic. So to do what you wanted to do before, the vector action is what comes in, and then that's going to decide the movement. And then if it was 0, it would go to -1. If it was 1, it would go to 1. So how does that switch case? Oh, and then direction is just 0. Position plus equals 0. The hell?
No, it's either -1 or +1.
Yeah, but how did it ever, so it's in a switch case, how do you ever know that the valid values are just 0 and 1 for the vector action? Is that a setting in the brain?
I assume it's just from the data here. I don't know.
Okay, so if you want to set it back to random on your position.
Oh, back in here?
Yeah. So to fix this, then go up to the collect observations and add that random value.
Oh, okay.
So now it will know how far away the end position is. This max position is random. Wait, so what were you setting?
The position of that large reward. It's large goal position. I can just pass that in.
Yeah, so large goal position is the one you wanted.
Okay, because that's now an observation.
Yeah.
Okay.
But
now it just kind of like knows what the position is, right?
Only of the goal. So it will know how far away it is and knows its position, and so should gradually learn over time which one to pick first. Okay. One thing I don't understand is how it knows to only use 0 and 1 when you're getting a float back. Oh, it's casting it to an int. So which is just doing a rounding. Okay, line 32.
That's right, because I think the values you get are between 0 and 1 for that, right?
Yeah. Yes. So I think if you trained that now, we would actually get something out of this.
Okay. Well, let's give that a try. Off the training, and we'll go back into the academy. Switch back over to external. Up. We can start training. Stuff's starting to make a bit more sense now.
Yeah.
I really do think we can do some really cool stuff to kind of get it down. I get the feeling that once you kind of understand how to make this system work, probably pretty damn easy to do some really cool stuff. Gotta get past the
learning curve.
Yeah. Observation size mismatch between agent and basic brain. Was expecting 1 but got 2.
Basic frame. Agent. So you gotta go.
Basic frame.
No, maybe it's a setting.
Oh, for size. Oh, that's right. It's in the editor.
Yeah, that's what I was thinking.
There's a size for observation. Space size observation, and it's going to be 3. Oh, okay. And that's the continuous or discrete, is if it's a set one or if it's a
Wait, what?
So it's if the observations are a set size or if it's a continuous stream of observations, I think.
Got it.
I think that's why it was always 25 before. It was just kept pumping things into it. Oh, couldn't connect. Hold on, I gotta restart the trainer again. Oh, cool, thanks. Plan on doing some more on this stuff once I kind of understand things. It's confusing, but pretty interesting. Definitely need to redo a setup then, since it looks like that stuff's changed quite a bit. Okay, should be starting up. And still an error.
No, okay, so it's expecting one.
Oh, I'm an idiot.
Stacked vector.
I changed the wrong value, the wrong field. Stacked vector was this was observations. I changed actions.
Okay.
Yeah, let me cut this again. What was it? Control Q. There we go. Okay, so if I adjust the correct value, I just need to turn that up to a 2. Stops running. Come on, Unity. OP. There we go. Oh, and I did OP again. I stopped and restarted it instantly. Always a blast. Okay, so that should be a 2, and that should be a 2. And I need to rerun the thing again. That I need to rerun that. I'm gonna get an error in here saying it couldn't connect. Okay. Once this launches, we should be able to start training and have it learn some stuff. Going? Oh!
Hmm.
Why was
Agent.
it a 1?
Mismatch between agent and brain. Click on the agent. Basic agent. No. Agent shader. Yeah, that does not really help. Small goal. Visual vector action. Observations. Agent monitor canvas. A mismatch between agent. Super weird.
Yeah, so vector observation. Oh, it's literally hard coded in here. If it's not equal to 1. Oh, okay. So what the fuck? So
change to continuous. Yeah. If it's not, if it's discrete, then it's only 1. Weird.
Huh. Okay. Well, let's restart it again. I probably went too fast on that. I probably hit play a little too early. See? Yep, I did. Come on. Little window. There we go. Okay. Now, get smart, Unity. Get some smart things. Oh, man. Was expecting 20, but got
20?
okay.
Go ahead. Oh,
So
space
space
size.
size of
2?
I'm confused. Yeah. Okay. So 2, and then what should stacked vector be then?
I don't know.
Number of states that will be stacked before being fed to the neural network. Okay, that should be a 1. Okay. Maybe I should use the mouse over a little bit more often. Ah, damn it! And I didn't start the thing first.
It sucks.
I do like a little script when I hit play that just kicks off the thing in the background and waits for it.
Don't play until play.
Okay, cool. And then we hit play.
Big money.
Right. And it's training. Kind of.
Weird. What the hell is it doing? Oh, you put go back to the code because I think you got the max and min position confused with the. Okay, so you're setting max and min position, which is like changing when you can recall reset, I think, is the problem.
Yeah, I was setting max. Should I leave max the same, you think? And just set the goal position?
Well,
setting the goal position to the max.
So agent reset gets called, which then the position gets set somewhere.
Yeah, it just picks that random position. I don't even know if the min and max positions really matter, because once it hits those, it just marks it as done anyway.
Oh yeah, well, position 0 is literally
That's
position
starting. It's just 0, 0, 0.
Oh yeah, okay.
And then it's going up or down by 1 until it hits a goal. Like, it should always hit the goal before it hits the min or max, unless something goes.
Yeah. Okay.
Oh, actually, I guess it would. Well, doesn't it stop when? Yeah, it stops when it hits 1. So I can't think of any situation where it's actually gonna get past them like these. These should never actually happen.
Yeah. Okay. Never mind.
So it should be training now, but I assume it's just gonna be slow.
It's gonna be hard to tell because I think go back and look at the console. You're gonna get thousands of things, so the reward should be going up, but it's going down.
Well, this one's going up. The mean reward.
Yeah.
It's going pretty consistently up.
Oh well, wait. The reward. Depending on how far away it is.
Yeah, there's going to be a limit to how high it can go, right?
So the other part of it, I think, is
that standard deviation?
Maybe, but I think there's a problem with the way we're calculating the reward now because we're moving that position around, and so the reward is going to be changing based on that random number, which is not what we want.
Why?
So yeah, well, actually no, it'll get.
It'll never get to 1, but it should get close, right?
Yeah.
With the most optimal path.
Yeah, so it should eventually know. Yeah, I guess so, because it should eventually know that the large goal, or whichever one's not moving around, it should learn its distance eventually, right? Because you changed the large goal position, is that right?
Yeah. The large goal changes position. But this reward is always greater than that small goal right now. The small goal is only 0.1, so it's never going to go to that small goal unless the large goal gets far enough away.
Yeah.
Right. So that's what I wanted to see, if we can get it to do that, and then if the large goal pops up at like 100 away, does it go for the small goal?
So,
but I think I need to train it with it being able to go up to 100 away, right?
Yeah.
We'd have to do pick a big. It looks like the values are going up, thanks to your Very correct observation. So if we kill this and we go back in and just crank that max up random, or like 130, so a third of the time it should be better to go for the small goal.
So where it says done, can you print the distance? Actually, no, we know that, well, yeah, okay.
Yeah, well, here the distance is 0, right?
Yeah, no, I'm trying to think of... I think we should print the large goal position and which one it's selected. Because so... Yeah, just do a print whenever small goal is selected. And the value, so yeah, and then add the value of the large goal position to it.
So we should only, once it's actually trained right, we should only see that when it's
however many far away,
when it's
right?
more than whatever, yeah, like 91 or whatever, or 100.
Points,
it's
yeah,
minus
points
0.01 per step.
Yeah.
So.
Did you need to start the console? Okay, I'm gonna call it at midnight, by the way.
Yeah, no, that totally works for me. I'm already extremely tired. Give this go. I think we at least got a good foundation for doing machine learning stuff, though.
Yeah, I think I know what to do now.
So right now we're gonna get it semi-randomly while it's training, right?
Yeah.
Oh, and here, I guess, yeah, you can see how many times it's running through it. This is how many times it's finding the small one. So
yes.
You're seeing nothing, but it's already found the small one hundreds of times, and which means it's done, yeah, thousands on the other.
And so, yeah, we should see small. So small's at -3, right?
What do you
So
mean?
it'd be minus 1,
yeah.
minus 2, minus 3.
And then you get a plus 0.1, so it gives us like a plus 0.7 for getting the small if we go straight to it.
Yeah, and
that
so
would be the highest reward possible is 0.7.
So 107, anything above 107 away. So we should gradually only see that number become over 107, right? Because you're subtracting 0.01 every movement, and you're increasing by 1 for that decision.
It would be in the 90s, right? Because the max we can get is, what did I say it was?
0.7.
Is it 0.7 or 0.07? It's 0.07.
So -3, right? Yeah, 0.07.
The best we can get is 0.07. So to get down to 0.07, we just do 93 steps, and we can get
okay,
it. So if
sorry.
it's more than 93 away, we should. Let's see. Let it train. Let it train. Let it train.
I do feel like the numbers are getting bigger. So yeah, what would have been interesting would be to keep the average.
Oh yeah, and just
small.
show the average going up.
Yeah, you want to do that?
Yeah, let's do it.
It looks like it is working, but
it does. Yeah, it seems like it, but.
So if you just made like a variable and added and divided by the number of times, get the total runs by the total. Just maybe 2 static variables in there on the agent.
Yes.
Actually, reset seems, yeah, it might not even need to be static. I don't know, but yeah. So you do a float of total. What do you call it? Total score or whatever, right? Or actually, the agent has these values in them, right? But but we only want it for small. So this would be like total small score. I don't know. And then equals 0, and then another int with total small iterations. I don't know. Or collection or whatever. Yeah.
It's the number of times it got selected,
Yeah,
right?
exactly. So then add that up and then print out the average.
This is actually the total small. This is the total distance, right?
Oh, yeah. This
large.
is the total. Yes, yeah.
Total distance too large.
Yep.
Okay, and then we add to that each time.
Yeah, only when we... Yeah.
It's actually a large goal position. It's the same as the distance. And then total small plus plus. And then we can just do that plus average plus total distance to large divided by cast as a float total small selected count. That's right?
Yep. Looks good.
Okay, and I think I did not start that already. Get that going. And then we should hopefully see that number go up.
And then sleep.
Yes. So that number starts looking better. We know it's working. And yeah. I think if this works, I think you get a pretty good idea of how to make it find anything. Go to anything. You know, and I think it'd be a cool it'd be interesting to be able to get it to do like a maze or something.
Yeah. What the heck? It's never going to small right now. Is that right?
Weird. It was just going to small all the time. What's going on? No episode was completed since last summary.
Oh. Do you need to start? Change the name on the thing. So quit out of that and then give it a new name. Oh wait, there it is. Look at your console.
Oh.
It just was like lagging out.
Just didn't want to show, huh?
Yeah.
Here, I'll run it again and let it run for a minute. Moving to small. Okay. Yeah, that's weird. I wonder why it was logging.
Yeah.
Oh, you know what? Wonder if it's related to me moving this.
I bet it was.
Doing something else.
Move the incrementers up too. Not that it matters. Just gonna move this slightly off.
Yeah, you're right. Okay, let's try that. And what's going on, kiddo? You gonna bring your cookies on the stream? He's hiding.
Nothing but you. I was live streaming super loud.
Oh, apparently I was ruining his Minecraft live stream.
I was live streaming Hulu too.
He's been live streaming all day.
3 hours straight.
Nice.
Alright, is it starting? Come on, start up. There we go.
Sounded angry.
He does sound a little angry. Not happy. And loud during his live streams. Okay, yeah, now we're seeing numbers.
Nice.
Cool.
Yeah.
70s.
Sitting around 70. Come on.
Getting dumber. Harder again. Of course, like, I'm expecting this immediate learning, like it's just gonna learn instantly. I know that like in the and this is going relatively slow, I think, because we're printing out console logs.
Yeah.
In the sample stuff, like they show going through and building like headless executables and then running against those for the data.
Yeah.
Just because it won't have to render and it'll go
Really way faster.
Yeah. I mean, the debug
Makes
log
sense.
is literally the slowest thing we could add.
Yeah.
Well,
we're 4,000 iterations in. I don't know. I feel like we're missing something still.
Certainly possible. Mean reward is slowly going up a tiny little bit at a time.
It like goes up for a while and it goes down farther.
Oh, the average one there, yeah. We should probably have just kept like a rolling average though.
Yeah.
That would have made a lot more sense. We could see the average going up because we're just adding on small amounts to this giant thing now.
You want to like I don't know, make an array of 5 values or something and
yeah. That instead. Okay. That there, that stopped. Opening the wrong window. Playing with the diagramming tool. It's pretty damn cool.
nice.
Just make a... What is it? It's floats. And here we push it. Ah. Oh no, incubed. Large goal. And if distance is count. Just take 10.
Sure.
Okay, hop one. And then let's see, total distance is gone.
Yeah, we just average it on the size, right? Some.
Yeah, I was just trying to get the using link statement.
Oh yeah, okay.
So I could remember. I was thinking it was AVG, but it's apparently average.
Remove the total, the division. Yeah, that doesn't need to be there anymore, right?
Correct. In fact, we don't even care about the total count.
No.
Just leave it there. Oh, okay, so now we should have a nice rolling average of the last 10. And
There was a 16 in there.
Was there?
Yeah. Just after thousands of trainings. I don't know. I feel like... We'll see.
How many iterations do you normally train stuff on when you do this kind of thing?
On my master's thesis, I think I did hundreds of thousands.
Oh, okay.
So it just depends on when too much is too much.
But yeah, I think when I was doing the ball training, it was around like 40,000 or something before it got pretty good when I did it the first time through.
I saw a couple of higher numbers in there.
It looks... Oh. It looked like it was getting better, and then it just dropped way down. Like it's...
Yeah. Right. I mean, so you're subject to the random numbers each time.
That's true, yeah.
But... So I'm just wondering if the brain is giving us the appropriate vector actions.
Don't know.
What were your observations that you're recording again?
The large position and our current position.
Yeah.
So it's our cube's position, and then that went up the large ball. Well, I would say it's already midnight. If you want, I can just leave this training, and
just see how it goes tomorrow. Yeah,
we
sure.
can see what it has by tomorrow.
Yeah, let's do it.
Let it go, and yeah, we'll come back and check it out.
Make like Frozen and let it go.
Yep. Well, yeah, thanks everybody that's hopped on. I think we'll try to jump back in and see how this goes, and then try to do some more machine learning stuff. I don't know exactly what, but I'd really like to do a cool project where we actually control some bots or some AI to make it do something interesting.
That headless training is going to become super useful, I think.
Yeah, definitely at this rate. But maybe I'll figure that out tomorrow too before we do it. Just figure out how to do the headless train. I think it was pretty easy.
Yeah.
So get that working, and then we'll go through and train some more and figure out some more stuff. Cool.
I think while you were talking, it's been sitting around like 80s, 90s average typically. I only see a few 60s coming up now.
Yeah, it seems to be
Well,
better,
some
but then it
40s.
randomly pops down to some. It's weird. It must just be getting some really low numbers, I bet. Like those averages stay low for. Yeah, like if you look, it's basically they're staying low for 5 or 6 entries. I wonder if it's just getting like a 0 or 2 zeros or something, and getting a really bad number 1 or 2 times, and fucking fucks up the average because it's over the 10.
Yeah, because I guess if it's going to be...
I think if we discarded the outliers, it would probably be quite a bit better.
Oh, you know what? We messed up.
No.
The printout should be the reward, not the distance. Is that right?
No, I don't think so, right? Because we wanted to get the average.
Yeah, it's the same thing.
The average distance of the thing when it finds small. It should only find small when the reward is better. And I mean, it looks better, but I don't know. We'll let it train. Anyway, yeah.
Let's leave it. Yeah.
Thanks again. We'll leave it running, and yeah. If you got questions or anything, just drop a comment, and we'll see if we can answer them next time around.
All right.
All right.
Goodbye,
See ya.
everybody.